For 40 years, the basic grammar of computing has been exactly the same. You grab a physical mouse, drag it across a pad, and watch as a tiny arrow transitions onto the screen to follow your movement. You do the physical work, and the machine obeys. Google DeepMind is building a system to eliminate that process. They call it AI Pointer, and it is designed to replace physical hunting and clicking with predictive intent. A vision language model analyzes your screen layout and task history. Before you finish moving your hand, the system predicts your intent and snaps your cursor to the destination. For users with motor impairments, the AI smooths out slow, erratic movements to hit the target. This shifts the computer from a passive tool into an active agent that makes navigation decisions on your behalf. As the machine begins to act on what it thinks you want, the boundary between human command and autonomous machine action begins to dissolve. The software making those intent predictions no longer requires massive centralized data centers. The intelligence driving these new interfaces is collapsing inward, shrinking down to the size of a single local chip. Consider a new AI model called Needle, built by Cactus Compute. Needle does exactly one thing. It understands a request and generates the correct software tool call, like booking a flight or querying a database. Look at this volumetric comparison. Needle has just 26 million parameters. As it scales down, it's 1,000 times smaller than a standard large language model. This architecture allows it to run at 582 tokens per second on a mobile chip, using just 76 megabytes of memory. Shifting routine agent tasks to cheap, tiny local hardware removes the economic necessity of cloud-based frontier models for most day-to-day computing. Pushing that kind of speed to local devices creates immediate friction. When AI agents can write and execute code at hundreds of tokens a second, they generate massive amounts of software that technically works, but lacks the engineering discipline required for humans to maintain it. Developers are already moving to enforce that discipline. An educator named Matt Pocock published his personal directory of agent skills, strict rules that force AI tools to follow senior engineer practices. Within days, the repository reached 75,900 stars. While the developer community focuses on maintainability, the security implications of autonomous agents are becoming more severe. On the offensive side, Google recently disclosed that hackers used an AI model to successfully generate a working zero-day exploit, an attack targeting a vulnerability that was previously unknown even to the software's creators. On the defensive side, Anthropic's Mythos AI recently conducted an audit of Curl, a tool used by billions of devices. This radar represents the AI scan, which successfully isolated a genuine, critical vulnerability that human maintainers had missed for years. Human infrastructure is the middle ground in a technological war. The same automated reasoning is deployed simultaneously as the ultimate weapon and the ultimate shield. The escalating weight of these autonomous AI actions is now beginning to slowly fracture our human legal system. There are now 501 active AI-related court cases globally, testing the limits of how we assign responsibility to digital agents. The most severe cases involve direct physical violence. A second lawsuit has been filed naming an AI chatbot company as a contributing factor in a mass shooting. The legal theory tests whether a chatbot's responses can be considered a substantial factor in a user's radicalization. Because no historical precedent exists for autonomous digital agents, these parallel lawsuits are authoring the legal boundaries of corporate liability in real time. We are attempting to build a legal framework for a technology that changes faster than a court can issue a ruling. As the legal system struggles to adapt, our educational foundations are hollowing out. National math scores in the United States have reached historic lows. This chart tracks the decline in math scores since 2012, intersected by the climbing line of generative AI adoption. Students are increasingly using AI to produce the correct answer while bypassing the mental process required to understand it. This is a modern repetition of Fred Brooks' no silver bullet principle. AI can automate the accidental complexity of syntax and boilerplate, but it cannot solve the essential complexity of human reasoning. These efficient models weave themselves into an invisible infrastructure. Zooming out, we see a network handling our tools. navigating our screens, and mediating our laws. As AI settles into the invisible background of our lives, the burden of maintaining foundational human reasoning